y equals the square root of x. A blank graph here. And off to the side, we're going to do a cool little XY chart.
Cool.
It's cool. So you tell me yes or no. Normally you can plug in any random x value you want, but would this be okay? -2 for x? How come?
Because it's square root.
We want perfect square numbers, that's true, and 2 is not a perfect square, but there's another big problem here. We're taking a square root. You can't square negative numbers, can you? So those wouldn't be any good. What's the smallest number I could use for x? What's the smallest number I could take the square root of? I can take the square root of 4. That's true. But that's not the smallest number. I can take the square root of 1. Square root of 1 is 1, but there's a smaller number than 1. 0. So we're going to use 0. Smallest number here is 0. Square root of 0. So there's the first point on the graph. 0, 0. There are no points on this graph to the left of where we just started. Why not? We can't have any negatives. Okay. What about x equals 1? We got to speed this up. X equals 1? Then y equals 1. I'm seeing a lot of uncertainty out there. The square root of 1 is 1, isn't it? Okay. Now I'm going to skip ahead to 4, because 4 is pretty easy to take the square root. Now let's see if we can have a little more confidence on this one. What's the square root of 4? Alright. So the graph looks like that. It doesn't go completely flat. It continues to increase a little bit, like that. Now what you're going to see, though, would be, obviously you're going to have other numbers in the function. Like there might be a number inside, there might be a number outside here, there might be a number in front. So what we got to figure out is how do all those affect the graph. So write this: y equals a times the square root, and then inside the square root have x minus b, and then outside put a plus c. You still with me? All right, check it out. This is just watching. Put your pencil down. Look at the screen. We got to figure out what all of these values, a, b, and c, what effect does it have on this graph right here? So right now I've got, can you see where my mouse is pointing? I've got f of x equals the square root of x. That looks like our graph, right? So I'm first going to change values of c. Values of c would have gone outside behind the square root, right?
Mm-hmm.
Right, Mason? Right? So I'm going to change c across the slider. Notice what happens to the graph if I change c. What's happening to the graph? Where is it moving? How would you describe the movement?
Up and down.
It's moving up or down. So where I have it now, c is 2.5. It's positive 2.5. Did the graph move up 2.5 or down 2.5? Moved up 2.5. Notice where the transformation occurred. Would you call this inside the square root or outside?
Outside.
Outside. What if I change it to a negative number, like negative, 2.5? What direction did it move? So what can we conclude about what c does to the graph?
Moves up and down.
So go back to your notes, draw an arrow to c. If I change the value of c, what effect did it have on the graph?
Up and down.
Up and down. Moves graph up or down. How did we know if it was going to move up? It was positive. So put a plus sign. Plus moves up. minus moves
Down.
down. We okay about describing it that way? Well, you guys are pretty clever. If this C moved the graph up or down, what do you guess is going to happen if I change B?
Right.
Pretty logical guess, isn't it? Let's take a look. So I'm going to change C back to 0. Now I'm going to change B. Remember, B would be values inside the square root. Were we right? Now, I wish I could make this bigger. This is kind of hard to see. Squint your eyes. You really need to see this, otherwise you're always going to get these wrong, and it's a hassle. What direction did the graph move?
Right.
But take a look at the equation.
Negative.
It's x minus 2.1. If it's x minus 2.1, what direction did it actually move the graph?
Right.
To the right. Okay. Now the graph's moving to the left, correct?
Yeah.
But take a look at inside the equation. What do we have inside the equation?
Plus.
X plus 2.7. That moved the graph to the left. So the numbers inside move it left or right, but doesn't it kind of go opposite of what you would think? Let's write that down. These numbers move the graph left or right, but this time a minus sign moves what direction? Moves to the right. Plus sign moves to the left. We're kind of out of options here. B moves it left or right, C moves it up or down, so what the crap can A do? What were you saying? Yeah. Check it out. Let me change B back to 0. What's happening to the graph if I change A? Do you see what's happening? If A increases, doesn't the graph get steeper and steeper?
Yep.
If A decreases, the graph gets not steeper, unsteeper.
Does that mean it can go steeper downwards?
Well, what happens if A turns negative?
Steeper downwards.
It flipped upside down, right? So A doesn't move the graph, it affects the shape of the graph. If A gets bigger, it stretches the graph. If A got smaller, it shrunk.
Yeah.
Let's write it. Yeah, you got the right idea. So this is actually called the vertical stretch. Yeah, it's called a vertical stretch. Now we need to clarify this. It stretches if A is greater than 1. If A is greater than 1, it stretches the graph up. If A is less than 1, write it this way though, write it exactly how I'm writing it. If A is less than 1 or greater than 0, it has to be greater than 0, then it shrinks. If A is greater than 1, it stretches the graph out vertically. If A is between 0 and 1, like a fraction, 1/2, 2/5, then it shrinks the graph down. What happened if A was negative? Remember what happened to the graph if it was negative? Didn't it flip upside down?
Yeah.
You guys have seen all of this before, by the way. Does this look at all familiar? I'm not even talking about this year. You've seen it last year in secondary 2 with other types of functions, but you've seen all of this before. This shouldn't be new. This is what you would have seen last year. Let me change the function here. You would have seen it like something like that. What is that? It's a parabola, right? X squared. What happens if I change C? Isn't the graph moving up and down still?
Yeah.
What would happen if I change B? Come on, guys, focus. Doesn't it move left and right? What happens if I change A? Makes it fatter or skinnier? You've seen all this before. This was a whole big unit back in secondary too, so this shouldn't be a surprise. It's all the same stuff, just with a different shape of a graph. You with me still? So all you're going to see on your homework, 4.8 super easy. For an example like this, it's going to give you something like that and ask you to choose the correct graph out of a choice of 4.
Four choices.
So it would look something like this. They'd have this as an answer choice, or it would have that as an answer choice. It would have that as an answer choice, or that as an answer choice. Well, all I got to do is consider what this plus 2 does to the graph. Does it move it up, down, left, or right?
Down, up.
Moves it up
Choose D.
2 units. Which one has been moved up 2 units?
Choose D. Choose D.
So pretty much that's all you're really going to have to do on your assignment is just choose the correct graph out of choices. You guys think you can handle that?
Yes.
The other type of function you're going to see, besides a square root, is a cube root, okay? Same thing applies. You guys listening? Same thing applies to a cube root. The only difference is the shape of the graph's a bit different. Rather than having, still has 1, 1, then it goes all the way out to 8, 2. But then you also have your negatives. So a cube root graph looks something like that, but the same things apply. If it's outside the cube root, moves it up or down. If it's inside, it moves left or right. If it's in front, it stretches it up and down. Guys think you can handle that?
Yeah.
Okay. There's one problem that's been throwing everybody off on the homework. It looks like this. Y equals the square root of 9x. Write this one down. Every single one of you are going to have a problem that looks almost like exactly like this. And once you see what you need to do, it's pretty easy. It's not that big a deal. Write exactly what I write. You ready?
Yes.
You okay so far with that? All I did is factored out a 9. But notice I kept it inside the square root. I'm going to erase something here. I don't want you to erase anything. What if it were just the square root of 9x? Wouldn't the 9 come out as
3. Yeah.
a 3? Well, it's the same thing here, even though it's x minus 3. That 9 is going to move to the front as a 3, and then on the inside you're left with x minus 3. So this would be a 2-part question on your homework. The first part would be to write it in simplified form. That's simplified form. The second part would be to describe the transformations. So how would we describe this transformation? This one right here is moving to the right. How many units?
3.
3 units. How would we describe this? It was a vertical stretch. By a factor of 3. That's probably the most difficult problem you're going to have on your assignment, is something like that. Okie dokie? Okay. Gather your stuff.